Hello everyone, welcome to the discussion of Module 1 of General Mathematics Quarter 1 entitled Functions and Functions as Models. Let us first define what is relation in mathematics. Relation pertains to set of ordered pairs. The set of all first elements of the ordered pairs is called the domain of the relation, and the set of all second elements is called the range. For example, we have here set A containing the set of ordered pairs 0 and 1, 2 and 3, and 4 and 5. The first element is what we call the abscissa or the domain of the relation. It is also called the x-coordinate of the point when plotted on a Cartesian plane. The second element is also called ordinate or the range of the relation. It also refers to the y-coordinate of the point once plotted on a Cartesian plane. On set A, the domain are 0, 2, and 4. So these are the first elements of the ordered pairs. We have 0, 2, and 4. The range are 1, 3, and 5. These are gotten from the second elements of each ordered pair. We have here 1, 3, and 5. So that is how we identify the domain and the range of the set of ordered pairs. Now, let's define function. Function can be described by the following. We have here function as corresponds to. To each person, there corresponds an age. To each item in the store, there corresponds a price. To each automobile, there corresponds a license plate. Because every automobile, there is only one license plate being registered on the Land Transportation Office. To each particular circle, there corresponds an area. Next, function as depends on. What causes tsunami? We all know that earthquake is the cause of tsunami. If the earthquake increases its magnitude, then the tsunami will be severe. But if it decreases, the magnitude of the earthquake decreases, then therefore the force of the tsunami will decrease as well. So we have tsunami's force depends on the magnitude of earthquake. Next, function as depends on again what causes flood. We all know that is the rainfall that affects the flood. It will cause flood. And rainfall affects the level of the flood. How? If the rainfall increases, then the level of flood will increase. If the rainfall decreases, then the level of flood will decrease at a low level. So therefore, flood's level depends on the amount of rainfall. And to formally define function, it is just a relation or rule of correspondence between two elements, the domain and the range, such that element in the domain corresponds to exactly one element in the range. To further understand function, let's study the following. We have here four set of ordered pairs. All we need to do is to identify whether each set of relations are functions or not. So let's begin with set A. First thing to do is to check the first elements of its ordered pairs. We have here 1, 2, 3, and 4. If no first elements repeated, then therefore this relation is a function. Okay, next, set B. Let's check the first elements. We have here 3, 4, 5, and 6. No first elements repeated. Then therefore, this is a function. Okay, I will give you a strategy for you to easily understand the process on how to identify whether the set of ordered pairs is a function or not. So, in an ordered pair, so the x variable, the first element, x, we have to let that be a boy. And the second element, the y coordinate, we're going to have to let that as a girl. Okay, in the concept of function, guys, the boy, which is the x variable, must be loyal to his partner, the girl. Okay, since if we're going to partner x, the boy and girl, they are couple and they have a relation. So for their relation to be a function, the boy must be loyal to his partner, and that he doesn't have any other girl in his life aside from that partner for the relation to be a function. And that is the easy way to identify whether a set of ordered pairs is a function or not. Okay, now let's proceed with set letter C. the first elements are 1, 0, -1, and 0. As you can see, 0 has been partnered to both +1 and -1. We can say that 0 is not loyal to his partner. Therefore, the relation will not be a function. So that is not a function. Now, let's proceed with set D. Let's check the first elements. We have here A, B, C, and A. As you can see, A is being partnered to both B and D. So A is a two-timer. Therefore, this relation is not a function. Let's proceed with representations of functions. So we have here function as a machine. So when we talk about machine, it involves input, process, and output. Okay, here in our first illustration, we have here input 3. 3 is the input, and here is the machine in the equation, in the form of equation f of x equals x plus 1. So all we need to do is to substitute 3 on the x variable. So we have here f of 3 is equal to 3 plus 1. So we have to process this. So we are going to add 3 and 1. So 3 plus 1, that is equal to 4. And 4 will be our output. Okay. Next, we have here input A on the machine. Machine having the equation f of x is equal to x plus 1. We have to substitute A to variable x. So we have here f of A equals A plus 1. And our output would be A plus 1. Okay, so that is function as a machine. Now, function as a mapping diagram. I have here an illustration. On the first oblong, this is the set A. It refers to the input X, the domain. And the second diagram or illustration is the set B, the output Y, or the range. As you can see, each element on set A is being partnered to exactly one element on set B. So 1 is being partnered to 2, 2 is partnered to 3, 3 is partnered to 4, 4 is partnered to 5, 5 is partnered to 6. And this scenario, this mapping diagram, guys, is what we call one-to-one correspondence. And this is a function. So for us to identify whether a mapping diagram is a function, the only thing we need to do is to check if each element on the first set has only one arrow. Has only one arrow. Okay, we have 5 has only one arrow, 4 has only one, 3, 2, same with 1. To make it a function. So this is one-to-one correspondence. Next, we have here on the first oblong, we have the input 1, 2, 3. And on the second one, the output, we have the element 4. As you can see, the elements on the first diagram, illustration, is being partnered to the element on the second one, the output. So we only have one element here. So this is describing many-to-one correspondence. Lahat laban sa isa. Okay, when we check, each element here has only one arrow beside it. So 1 has only one arrow, 2 has only one, same with 3. Therefore, this mapping diagram is a function. And that pertains to many-to-one correspondence. Next, we have here on the input, we have the element 3. On the output, we have the elements 0, 2, 4, and 6. As you can see, 3 is being partnered on the 4 elements here on the output. When we check, 3 has 1, 2, 3, 4 arrows connected. Therefore, this is not a function. And this mapping diagram describes one-to-many correspondence. Isa laban sa lahat. Therefore, this is not a function. Next, we have here many-to-many relationship. If we are going to check the arrow beside the elements on the first set, on the first element here, in the first set, we have 1, 2 arrows being connected. Second element, 1, 2, 3 arrows being connected. And on the third element, we have 2 arrows connected. Then therefore, this mapping diagram is not a function. So that's how we identify whether each mapping diagram is a function or not. Next, function as a table of values. So we have here the first table, set A, we have here the x variables inputs, then the second row, we have set B, y values, the outputs. So the first thing we need to do is just to look at the values in the inputs. So we have here 1, 2, 3, 4, 5, and 6. As you can see, no numbers repeated. Therefore, this table of values is a function. Now let's proceed on the second one. So this table, the input is on the first column, the output is on the second column. Let's check the numbers in the input. We have here 2, 4, 3, and 2. As you can see, 2 is doubled. It is being partnered to 20 and 40. Then therefore, this table of values is not a function. Now, let's proceed with function as graph. So a graph of a relation is a function if any vertical line drawn passing through the graph intersects it at exactly one point. So the drawing of vertical line on the graph is called the vertical line test. So I have here sets of graphs. So when we draw on graph A, when we draw a vertical line, it only intersects one point of the graph. Therefore, this graph is a function. Okay? Graph B, when we draw a vertical line, it intersects 2 points on the graph. Then therefore, this is not a function. On graph C, it intersects at only one point. Therefore, it's a function. And graph D, the line intersects at 2 points of the graph. Then therefore, this is not a function. So that's how we identify whether a graph is a function or not. Now, this time let's analyze. So here is the direction. Identify if each set of objects is a function or not. So the variable x represents the input and variable y represents the output. So for number 1, we have here x, we have here automobile corresponds to plate number, being matched to plate number. So as you can see, every automobile is only matched to only one plate number. This is one-to-one correspondence, therefore, it's a function. Number 2, math teacher to student in a class. So this is one-to-many since a math teacher is handling not only one student in a class. Therefore, this is not a function. Number 3, zip code versus residents of the town. So this is one-to-many correspondence, and that is not a function. Number 4, students versus zip code. So this is many to one. Then therefore, this correspondence is a function. This is a function. Many to one. Okay, shoe size versus students in a class. So it refers to one-to-many correspondence. Therefore, this is not a function. Number 6, locker number to student. This is one-to-one. Therefore, it's a function. Number 7, cost versus product. So this is one-to-many. One-to-many. Since there is a lot of products having the same price or cost. Therefore, this is not a function. Number 8, family member versus social security number. This is one-to-one correspondence. Therefore, this is a function. Number 9, street address versus family members. So we have here one-to-many, and that is not a function. Number 10, height versus student in a class. This is one-to-many, and therefore, it is not a function. Now, this time, let's link the concept we've learned to real-life scenarios. We have here function scenario number 1. UMS 11A students list down their grades in general mathematics. Basically, each student has only one grade for general mathematics, but more than student can get the same grade. Okay, so this scenario is a function. We can represent this as a mapping diagram. Here on set A, we have here the name of students as the input, and set B, we have here the Gen Math grades as output. So, for example, Ashley got 90, Dean got 89, Sherwin got 95, Andrea got 95. So, if we're going to look on the arrow being connected on the elements on the first set, okay, each element here has only one arrow. Okay, so therefore, this is a function. And now let's proceed to the questions. So, on the previous situation, here are the guiding questions. So, is it logical that each student gets only one grade? Of course, yes. So can we consider this as an example of a function? Of course, yes, as stated a while ago. Is it also logical that more than one, say 3 students, can get the same grades as the others? Is this scenario a function? Of course, yes. Number 3. Is it possible that one of your classmates does not have a grade in Gen Math? Is this an example of function? Of course, no, it's not. And number 4, how are we going to represent the function scenario into a function model as x with the name of each students and y with the grades of students? So guys, here is a function model. Y is equal to x. So grade is being corresponds or matched to a student. So this is y equals x. Next, function scenario number 2. In our canteen, all kinds of juices are worth 5 pesos each cup. There is mango juice, pineapple juice, guava juice, chocolate juice, buko juice, and many more to choose from. So Anna wants to buy 2 different juices, while Brenda wants to buy 3 different juices. So we have to represent this as a mapping diagram. Set A, we have here the number of flavors of juices being chosen. And then set B, here are the price per cup. So if they chose one flavor of juice, that would cost 5 pesos only. If 2 juices flavor, that is 10 pesos. And if 3 flavors has been chosen, then that is 15 pesos. So as you can see, each element on the first set is being matched on exactly one element on the next set. Therefore, this is a one-to-one correspondence and it describes a function. Okay? With the situation a while ago, we have here the questions. So can we consider the relation of the total price of what Anna and Brenda will pay to the number of juices they're going to buy a function? So based on the diagram, the answer is definitely a yes. So number 2, will the total amount of payment be your input X or output Y? What do you think is the answer? So the answer here is output. Since the amount to be paid that depends on the number of juices they wanted to buy. Then therefore, the number of juices is the input. This is the input. Okay? Remember, the output depends on the input. The value of the output depends on the input. So how are we going to represent this as a function? So that is f of x. Okay, remember that y can also be written as f of x. So we have here f of x equals 5x. So why 5x? Because in the scenario a while ago, each cup of juices in their canteen cost 5 pesos. So we have here 5 times the input, which is the number of juices as variable x. So we have here 5x. A while ago, when we are going to add the number of juices they want to buy, that is all 5. So we have here to substitute 5 on the x variable. So we have here f of x is equal to 5 times 5 equals 25. Therefore, both of them will pay 25 pesos for the juices they want to buy. Okay. Next, we have your function scenario number 3. A grade 11 student who decided to ride a tricycle going home from school noticed a table of fares posted inside the vehicle. So he read the fare guide during the trip and found out that he needed to pay 10 pesos as the basic fare that covers a 5-kilometer ride and an additional of 1 peso every exceeding kilometer. So we're going to have to represent this as this mapping diagram. So if you travel on the first set, we have here the distance in kilometer being traveled. And on the next set, we have here set B, the tricycle fare for the distance being traveled. So if you travel 3 kilometers, that would cost 10 pesos as your fare. If 5 kilometers, that is also 10 pesos. If you travel 6 kilometers, that would cost 11 pesos because it has an excess of 1 kilometer. So 1 plus 10 is 11. So if you traveled 7 kilometers, it has an excess of 2 kilometers. So that is 2 plus 10. Therefore, you are going to pay 12 pesos for the fare. If you traveled 8 kilometers, there is an excess of 3 kilometers. That is 3 pesos plus 10. Therefore, you're going to have to pay 13 pesos for the ride. As you can see, guys, each element of the first set has only one arrow connected beside them. Therefore, this is a function. Now, we have to answer the following questions. So with this situation, what did you notice? Did you find the scenario different from the previous situations? Of course, yes. Why? Because there are more than one condition. As you can see, 10 pesos covers only 5 kilometers, and there is an additional 1 peso if you exceed the basic coverage of distance, which is 5 kilometers. So what seems different? So that is the possible input are divided into pieces, right? We have 5. If you traveled 5, less than 5 or less than equal to 5, then you're gonna have to pay 10 pesos. If more than 5, then 10 pesos plus the additional 1 peso per exceeding kilometers. Okay, so next question. Can we still consider this situation a function? Of course, yes, and that is called a piecewise function. Okay, now with this situation, how can we make a model, mathematical model for this? So we have to consider k as a total kilometer ride and t sub k as a total fare. So we let k be the input and t sub k be the output. So with this, we can have the formula. So this is the piecewise, this is how piecewise function look like. We have here the output t of k is equal to, then we have to draw a brace. Then we have here 10, that is equal to 10, as stated here, if the kilometer ride is less than equal to 5. So that is the payment for the fare. But if you traveled more than 5 kilometers, then therefore you're gonna have to pay, you have to bring down 10 here. Then we have here plus. So since we have here and an additional, that is addition. So plus, we have here 1 peso exceeding every exceeding kilometer. So how are we going to compute for the exceeding kilometer? That is k minus 5. So quantity k minus 5. So this is the formula if you travel more than 5 kilometers. And that is how to create a piecewise function. In a piecewise function, the input is divided into pieces of a formula, with each piece having their own condition or rule to deduce the output. It shows a set of different intervals that behaves differently. So in your early stage of learning math, you have already encountered this piecewise function. That is the absolute value defined as f of x is equal to negative x if x is less than 0, and x if x is greater than or equal to 0. So x less than 0 and x greater than equal to 0 are the interval notation referring to the condition. Okay, so that's it. Now let's proceed with the function as model. We have here a scenario. In this time of pandemic, some businesses took action to adapt to the new normal. Boyet, a computer shop owner, came up with an ingenious solution which he called Rentcom. This concept is to lend a computer, which is packed with a device that computes or counts the time usage, to a customer. The renter needs to pay an initial of 600 pesos for a total of 500 hours and an additional amount of 2 pesos for the excess time per hour. So the first thing to do, guys, is to identify what is the input and the output of the problem. Okay, looking at the problem, we all know that input X is just a total number of hours, and the output would be the total payment, since the total payment depends on the number of hours of usage of the computer being rented. Okay, so what will be the formula? So the formula would be, the function would be a piecewise function. So the first one, we have here f of x is equal to, we have here the brace, 600 pesos if x, the total number of hours of usage, is less than equal to 500. So that is 600 pesos. This is the amount you have to pay. But if you excess time for the usage, so if your time of usage is greater than 500, then this will be the formula. Bring down 600 as stated on the problem. We have here the word and additional. So we have here the plus sign. We have to add amount of 2 pesos. We have to write here 2 pesos quantity for that excess time per hour. So how are we going to solve for the excess time per hour? That is by subtracting the total number of hours to the initial hours. Okay, we have here x minus 500. Okay, x minus 500. So this 500 came from here above. So you have to put that here. So this is the piecewise function of this problem. Next problem. Romer transferred a 3-leaf tomato tree from a pot to the soil. The next morning, Romer was surprised to see 3 new leaves have sprouted. The following day, he expected the tree to have 9 leaves, and he was right. So now let's identify the input and the output. So therefore, the input here would be the number of days and the output would be the number of leaves sprouted. Since the number of leaves sprouted depends on the number of days being passed. Okay? So with this problem, the function model would be f of x is equal to 3x. Sir, why 3x? So as you can observe, guys, in the problem, every morning, the leaves added 3. The tree added 3 leaves per day. So we have here the pattern plus 3 and plus 3 every day. So we have here 3 times the input, which is x. We have to multiply that. So that we have here 3x. So this is now the function model. Next, Lobrado family get a tour package to spend their vacation in northern part of Luzon. So they rented a van for 5,000 pesos plus an additional daily rate of 900 pesos. So devise a function model that will help them identify the total cost of the rented van. So we're going to have to identify the input and the output. Okay, so we have to let the input x be the number of days since we are talking about renting a van. Okay? And input, guys, that can also be called as independent variable. And their output would be the total cost of the rented van. And this output is also referred to as dependent variable. Why dependent variable? Since the value of the output would depend. It will depend on the value of the input. So that is why it is being called dependent variable. Okay, upon checking and understanding the problem given, so the formula, the function would be f of x equals 5,000 plus 900x. So in the formula in the problem we have your rented a van for 5,000 pesos. We have to write here 5,000 after the equal sign. Then plus, we have to write here the plus sign. An additional daily rate of 900. We have here the number 900. We have to put 900. Since we are talking about daily rate, then we have to multiply that to the number of days. Since the number of days is x, then we have to put x beside 900. So therefore, this is now our function model. F of x equals 5,000 plus 900x. Next, Paul is planning to hold his 48th birthday party in a private resort for at least 2 days. Knowing that his friends love to sing, he rented a videoke machine for 800 pesos and an additional of 300 pesos for each day of extension. And since we're talking about renting, therefore the input would be about the number of days and the output would be the total cost of rented videoke machine. So here is the function model based on the problem. This is a piecewise function. So f of x is equal to 800 pesos, as you can see here, when the number of days rented is, that is x is less than equal to 2. So where we got 2, as you can see, it's stated here, at least 2 days. You have to plan of celebrating his birthday. Okay, we have another formula, guys. Bring down 800, since we have here, he rented a video machine for 800 and we have the word and, so we have here plus sign, additional of 300 pesos for each day. So we have 300 pesos for each, that is multiplication, day. Since day is our input, that is x, so we have to put x beside 300. So this is the formula to be used to compute the total cost of rented videoke machine if the number of days rented is greater than 2, that is x is greater than 2. So this is how to create a function model using a real-life scenario or situation. So I am thankful for your time of listening to my discussion. So thank you for watching.